I'm going to talk a little bit about the largest platform that exists today, the most successful project in IT history ever, or project of any kind of humanity, which is the web. I will start off with that. I will then translate, or I will then switch to talking about digital transformation within education. And I will use that as a proxy simply to illustrate what's happening in industry at large outside of what's often called the FANGs, right? The Facebooks, the Amazons, and the Googles of the world. I will then close it up with talking about the challenges of integrating knowledge. So let's go ahead and get started. So I will start here by engaging you and asking you a question. I get to speak in many places around the world, so it depends on where I ask this question, I get different answers. But I will ask you, what was the first university in the traditional sense that has been continuously operated since its foundation? And I'm giving you a hint here with the picture. University of Florence, no, that's pretty good. The red tile. Other suggestions? Notre Dame, no. No. So it's in Europe, right? The country's right. It's Italy. Any guesses as to the name? Pisa? No. Pretty good. So, the Vatican? No. It's the University of Bologna. Okay? If you've never heard of it, you can look it up in Wikipedia. And as this often happens, other people might challenge you and might say, no, it's another one. As I said, it depends where you ask the question. But in the Western world, continuously operated, it is the University of Bologna. Any guesses as to when this was founded? Roughly? 13th century? Okay. Any other guesses? 12th century? No, earlier than that? 10th century? Yeah, so it's 1088, right? We're closing in on 1,000 years, right? Now, this was a great innovation at the time because prior to this, what did you have to do to acquire knowledge? It was a challenge, right? You had to go find somebody who was a master, an expert, and convince you to take you on as an apprentice. And when this was founded, for the very first time, there was a place you could go and acquire knowledge, right? This is what the classrooms looked like at the period. We haven't changed that much, right? There's still some people texting, right, somewhere other, right? So, yeah, innovations within, this is why I'm going to use education as an industry that needs to be disrupted, right? Now, fast forward 1,000 years, right? Does anyone know who this person is? Tim Berners-Lee, right? He's got an office about a block away from here. He's the founder of the web. And this picture of him is in his young days in the 80s when he was at CERN. And in many ways, he had the same challenge of those people prior to that university in Bologna. He wanted to reach out. By that time, there were a few thousand computers connected. You know, it was a big deal, right? Around the world. And he wanted to reach out and connect to the publications of other scientists. But it was assured. He had to call them on the phone. He had to figure out what protocols. There was all kinds of hoops he needed to jump through. So he spends the next 10 years thinking about what's the easiest, simplest possible way in which I can reach out across the wire and connect to a document. And so at the beginning of the 90s, he proposes what becomes the World Wide Web, and we have the explosion of connectivity. The first generation of the web that I will date at about 1995, right? The introduction of the Netscape browser. I'm sure some of you here used it in the early days, right? It was great. It was revolutionary, right? The big innovation at the time was an image tag, right? But it started to connect the world in terms of documents. And I will say that 10 years later, 2005, we get the second generation of the Web 2.0, and where we start to connect not just documents, but we start to connect programs, and we start to connect data. And I will make some observations about some of the transformations that have taken place. Harvard University, the first year they went online, more people took Harvard courses than had taken Harvard courses in its entire history, over 300 years, right? Khan Academy, more children studying Khan Academy than the entire school-age population of the United States. WebMD, right? Whenever you look it up, my son had a little bump in his neck and he says, "Dad, I think I have cancer," right? It's always terrible, whatever you look up, right? But 190 million Americans get advice from WebMD more than actually go to the doctor every year. eBay, in a country as litigious as ours, 60 million disputes get resolved by the dispute resolution system, an automated system, than actually there are civil cases within the US. The Huffington Post, however you feel about it, 5 years after its inception, it bypassed the largest circulation newspaper in the US, which is the New York Times. And this last one might be fun, especially if you're a Catholic. This application has actually received the imprimatur from the Vatican, which is the official license that yes, you can use it for confession, and it has and it has fun features like sin tracker, right? Okay, so you gotta love that, right? So this moves us forward. I talked about web, first generation, second generation, third generation. We're talking about, once again, reaching out beyond what we've had up until that moment. And the next generation, the one we're living through right now, that we're trying to realize that vision, is of connecting from virtual to physical. Remember, the first one connected documents, the second one connected to data and programs, the third one is reaching out into the physical world. And I'll spend a few slides talking about this, right? This was the vision. We could spend a whole hour just talking about why this is not yet working, but this is the vision, right? And within fast-moving consumer goods, that was largely realized, right? And it's already starting to transform industries. This picture is from a farm about 10 miles west of here. It's a beautiful place. I own shares here. I go once a week to pick up my vegetables. It is run entirely by women. It's a beautiful place. We often, take some food and have a picnic, and we spend, a really enjoyable afternoon, my family and I, on the weekends. However, the reality of agriculture is this, right? It is becoming an industry. I grew up in an agricultural area, and I thought I knew what agriculture was, right? You plant a seed, you grow it, you harvest it, you sell it. Seemed like a very low-tech thing. However, my image has been shattered, especially over the past years. I've talked to companies in this space. The amount of instrumentation that they're bringing to the field is just unbelievable. They're flying drones, they're doing weather modeling, the plots that are being planted get split up into something that looks like a jigsaw puzzle, and the tractor that goes out and plants seeds, it's actually executing a script. And every single sector of that field gets the optimum amount of seed, because obviously if you underseed, you hurt the yield, and if you overseed, you do too. And it's not just that, it's also the depth. The difference between being wiped out or having a successful harvest is 1 inch. And so these industries, or this industry, which you might think of as one of the oldest and one of the most conventional or traditional, it is now competing on information. The best information is winning the day. And so this is certainly one, and you can already see the headlines here. The land grab for farm data, data clarity on every acre from some startups. And of course, it's not just happening in old archaic industries. It's going across the board. If you follow sports, you must have seen some of the revolution that's taking place. Throughout the last year, the NFL spent a year outfitting every single stadium with RFID equipment, and every new shoulder pad. Somebody was saying that's the proverbial chip on your shoulder, right? But every single shoulder pad comes out that is being issued in the NFL has a built-in RFID chip. There's so much data being collected off the field that they don't know what to do with it. We had a student working on a thesis last year trying to quantify decision-making by a quarterback. And yes, you can laugh at the academic title, right? A quantitative geospatial analysis of quarterback decision-making, right? If we could only sell, right, these type of things, right? I'll emphasize the point again. If we go back to the days of Bologna, it's not that you couldn't find knowledge. It's just that it was really hard to get and it would take a long time. It's not that you can't study game film with, a number of analysts and spend the next 2 weeks trying to analyze all this information. It's just that now you can do it programmatically and you can do it fast. You can do it much, much faster, right? So another one about sports. Does anyone know who this is? Ray Allen, right? In the days he wore the right uniform, right? If you follow basketball. He was known, what was he known for? Three-point shooter, right? The best of all times until recently where things have gone crazy. And every time you saw him, go to the corner, especially if he was not on your team, you would say, oh no, here we go again, right? He was a threat. He was very effective, a weapon. However, if you start to think of him in terms of a visualization and a geospatial distribution of his shooting ability, you start to see a very different player, right? You start to see that, he's certainly very good from, the corner, and, there are many Sports Center highlights of him winning games here. However, who would have thought that 3 feet in, from the college three-point line, he's actually really bad. Also, as you start to study the perimeter, he's not as effective everywhere, right? Now, this paper here took 2 years to put together. You can see data, 2006, 2011. Now, with the equipment that's in the courts, you can do this real time, right? And so as you face an opponent, you can start to process this data. You can start to understand the patterns. You can start to test them against different defenses. You can start to test them in different gyms. You can start to get all kinds of different advantages as you start to study these pictures, right? And of course, this is a proxy for many of the same things that could be done in many other industries, right? In Formula One, right, the team that started to dominate a few years back actually had a team of data scientists in the UK and had deals with AT&T to be able to pipe fast enough all of the data that's coming out of Formula One races so that they could process the information and give feedback to the driver, right? So this is the type of advantages that we're seeing, right? There's already some cultural changes as well. This study comes from Cambridge, not Cambridge, US, but UK, where the police department saw 93% drop in complaints after deploying cameras, right? And the interesting thing here is that even after they stopped wearing the cameras, the number held. And of course, we are bumping up against the beginning of autonomous vehicles, and there's all types of standards. There's already a lot of DOT standards, the vehicle-to-vehicle, vehicle-to-infrastructure, and others, the connected car standards that are coming down the road and will have a tremendous impact, right? And this is just the beginning, right? There's many numbers that you can look at. Some put it at 50 million, some put it higher, some put it lower, but it's certainly an explosion. If you just think about everything that you have in your house that is connected, you can start to understand, the magnitude of this. And there's many issues that we could talk about. In my introduction, it was mentioned that I work a lot on security, but I have another goal that I'm going to today, right? So I will skip that. I will mention Web 4.0 briefly, just because blockchain is an important topic today, and it is yet one more extension. The big value added here is that for all the good things that we talked about when it comes to the web, there are many shortcomings as well. How many here feels safe when they go online? Raise your hand. One person, two. Wow, that's you're brave people. There's a big problems when it comes to security. There's big problems when it comes to censorship. There's a lot of challenges. There's no sense of chain of custody. There's a lot of things that blockchain technologies could come to help with. One of the things that we've invested most time is the decentralized nature of blockchain. If you're not familiar with the technology, it is a mechanism through which you can create a ledger, or you can think of it as a database as well, through which anyone in the world can add information to that ledger or to that database without you having to have trust in that person. There is a mechanism through which everyone can participate, and there's a puzzle to be solved that makes it computationally impossible for you to beat the network. And through this mechanism, you can add more transactions to that network without cheating, right? Because one of the first problems that anyone would look at, especially when it comes to value, is the double spend problem, right? And if you cannot cheat by introducing your transactions at a faster pace than the rest of the network, then there is a mechanism through which you can grow this network in a trustworthy way. It's not that different than Tim Berners-Lee, when he hit that perfect storm of low-cost computing, connectivity, and simplicity when it came to his standard. In this case, we have enough computing power throughout the world to be able to create these new decentralized networks and a mechanism through which people can add value without cheating. through that mechanism, you can get a bunch of more of new features that are derived from these protocols. And the big one we've been looking at is decentralization. And we've been looking at it in oil and gas. Most architectures that you look at today, I would say all, are hierarchical. If you take out the central control, the network stops functioning. These architectures, Bitcoin, and this is a market capitalization of 160 billion at the moment, and there's many variants, I know. But these networks themselves, if you take out a third, a half, or more of the nodes, this network continues to operate. It is decentralized, it is peer-to-peer, it has no central control. And so how can we re-architect and how can we implement this type of technology, especially in critical infrastructure, is a problem that we've been looking at. As you can imagine, anybody that has hundreds of thousands of devices like oil and gas is very interested in this, as well as other national interests. So now I will pivot and I will start to talk about what impact has this had in our industry, and I will use, as I mentioned at the beginning, our industry as a proxy to what's happening in the rest of the field. And the section here is called Education's Digital Transformation. So if we go back to that first generation on the web, and we think about the evolution that's taken place in university, the early days, the first days of the web, the first opportunities that existed there were of doing a lot of the labor that was transferred to students, graduate students. I'm sure that some of you, when you went to school, and you still see it in some places, are carrying around big stacks of exams, are distributing lecture notes and so on in the traditional classroom. A lot of the first effort in that first generation, this is the 90s, was to transfer that to learning management systems. And there were a few companies that were founded on those principles, Blackboard perhaps being the most notable one there. Now, that was the faculty pushing information into a learning management system, a student pool, all of it internal, consuming that resource, an internal publishing mechanism. At the end of the 90s, MIT took a radical position. These were the days of the dot-com boom, where every other university was starting its own online university, and MIT planted a stake in the ground and said, we will distribute all our content for free. And that was what was OpenCourseWare, right? And so this was a mechanism through which the faculty published to a content repository, the world pulled from that content repository. From a financial perspective, this makes no sense because this was all free. It was a big effort, it still is, of pushing a few thousand courses onto this platform. However, from a good to the world, this was widely successful, right? There was external publishing, there was no assessment, no guidance, or credit on this platform. And some of you that might have visited OCW would have seen this page. Now, fast forward about 5 years to 2006, 2007, comes the first generations of the MOOCs. These are the massive open online courses, right? And the mechanism here is the faculty pushes onto a learning management systems. The students of the world start to consume. There is some assessment, there is some guidance, but there is no credit. Now, the first course that was put, and this goes back to what I mentioned about Harvard, but the first course that went up for MIT was a course on circuits from the electrical engineering department at MIT. That course had well over 100,000 people sign up. Who knew that so many people cared about circuits, right? And even with the attrition, the amount of people, because there's a huge amount of attrition, even with the attrition, the amount of people that successfully completed that course was more than had ever taken that course in its entire history, right? So obviously that was a big success that led to a lot of internal discussions as to what education, what direction education should go in, what type of things should be done. And it led to the startup, if you can call something done between MIT and Harvard a startup, right? With 60 million funding, before anything is done, the edX platform, where their mission was to try to get the leading institutions of all of academia to become part of this platform and to deliver content to the world through it, right? That has diversified and much like the original mission of internal publishing that I mentioned, it has struggled to find a viable business case, but I think that's the case in a lot of startups, right? There's also variations of the MOOCs, right? Small private online. There was also flipping the classroom, where a lot of the tools, videos, resources that were made for online started to be used in the university as well. And you can see here an example of active learning. This is a case in where the student is no longer being asked to receive the lecture, much like I am doing right now, as I mentioned in the beginning. But they ask him to watch the lecture on his own, outside of class, and then come to class and actually do work and engage with the material. And you can see here one of the classrooms and how work is actually being performed. There were many other variants of this through the last years. And here comes a big shift. Does anybody have kids here who are within a 4-year window of starting college? How do you feel about the application process? I've heard it described as bad as it's a death march, right? It is one of the worst possible experience. I have a kid that's going through it, right? So it is just grueling. I mean, and it starts, I think, primarily the huge stress starts in high school, but it starts way before that, right? Even as you're moving into middle school, what kind of middle school are you going to go to? How is that going to prepare you? How are the courses that you're taking? It is, something that just baffles the mind. This is the set of criteria that is being used to admit new freshmen in the leading US universities. There's an ongoing joke between the faculty that if we were to apply to MIT today, we wouldn't get in, right? The applications we're seeing are insane. They are like, published authors, traveled the world, has started companies, it's just, and of course, all of them have perfect SATs, perfect exams. It is just, if you took all of the perfect applications, you would still have too many, right? So it is daunting, and anybody that's gone through it or is in the process recognizes the challenge. And the message is simple: few get in, right? You can see here the statistics for MIT and how the numbers are, have always been small, but are now getting smaller. And if you want to look at it in a different way, that's it. And the value that MIT has, advocated to the world is we're a good filter, right? You're here today because you think we know something, right? However, as I mentioned, the MicroMaster is going about it in a very different way. The MicroMaster says, day one, you're all in. No admission. Every single person can sign up. If you perform at the highest standards, then you get admitted. Think about this. This is very different than everything else that we do. When we hire in the marketplace, we hire largely on potential, right? Especially out of college. Athletes, when they go to the professional leagues, are hired on potential. And we've seen many a promising prospect just not deliver, right? In this case, when we admit in university, we're admitting on potential. This is a different model. We're saying, prove it, right? And this year, the MicroMasters, for the very first year ever at MIT, will have 40 students that did not come through traditional admissions, but all came through this other system, and where you competed against the world. Now, is it going to be easier? That's a big question. That's a big question mark. You basically have to stand out and you have to perform, but it's a different type of performance, right? So, and of course, we're not the only game in town, and here's where we start to, I think, be more of an example of what you're seeing in the marketplace. If you think about Udemy, and I will mention a few of these companies, this is a company that intends to be a marketplace. Just like the early days of the web established blogs or established online-only publications, there is a move to start to do the same thing now within education, right? Companies that are starting to be platforms. There's already the talk about a professor or a class being a brand. There are people on this platform making millions of dollars with a successful course. My wife was interested in doing some real estate investment, and she was considering the possibility of enrolling on a master's. She went on this platform, took a course from someone that had graduated from Stanford and had been doing this real estate investment for the past 10 years and provided targeted, really useful, practical, plus all the academic concepts advice. She paid $200 and in 6 weeks felt pretty comfortable about what she was doing, right? This is a very different model to what we do, right? We tell people, go through high school, go through university, go to grad school, and then maybe you'll start to, apply some of this. This is different. This is saying we can teach you now. And the marketplace is proving this model. If you are effective, this is not a brand that most people will recognize. If you are effective, the market will determine your value. And as I mentioned, these successful professors on this platform are making millions of dollars on their courses. And there's lots of them that are, in the 10,000, 20,000. There's another worthwhile mentioning university as well. It's called Udacity. Udacity is making the following proposition. Today, you will most likely change careers 4, 5, 6 times. You cannot afford to go through a traditional degree system. It is too expensive and it takes too long. We can train you in 6 months and we will not charge you a lot. They're charging, last I looked, was $100 a month. And they are graduating people in the degrees that are getting a lot of employment and a lot of traction, right? So things such as data science, things such as security, and so on, right? He is no slouch. He is a professor from Stanford in machine learning who was director of Google X. So he has partnered with industry, with Facebook, with others, and you can imagine that if you're taking classes from the engineers at Facebook, you know something, right? If you are performing in their curriculum, in their exams, you can't, the marketplace will, your training will mean something to the marketplace, right? There's another movement as well, boot camps. These are even more intense. They go a month to 6 weeks. And they range in free, which are hard to find, all the way till the same tuition as a university semester. This past year, the numbers of people who did boot camps is about 50% of the graduates in computer science across the country. So this model is tremendously successful, is making tons of money, and loads of people are signing up. And there's again a challenge to us in the traditional university as to how do we start to incorporate some of these models? How do we start to think about some of this? Obviously, it's having an impact. Obviously, people are being trained. What does that mean for us, right? The other opportunity here as well is data-driven education. Think about what Google can do by changing their front page. Google has the ability to receive feedback at a faster pace than anybody else. They can change their homepage and receive millions of hits in the next hour, and if that doesn't work, they can roll it back. Not only that, they don't really have to make a decision. They can roll out 50, 20, 30, 100 different front pages, and determining on how that succeeds, they can make a decision, right? Amazon can do the same, Facebook can do the same. What about us in education? Who determines how the lecture we are presenting, what the effectiveness of that lecture, right? What type of comparison is there, right? There is a tremendous challenge to our ability to teach because we have no data. We teach based on intuition. We've been doing this for 20 years. We're leaders in the field. Therefore, you should be good at teaching. That's a completely different question, right? Especially that in the elite college, you get promoted on the quality of your work, not in the quality of your teaching, right? And so for a second here, I'm talking about education, right? So how are we going to do this? We need to be faster as well. So I will speak about the traditional classroom, and those of you that will remember your college days, you will remember this. The first week starts of the semester, your teacher, your professor gives you an introductory lecture, there's no homework, right? Next week comes along, you start getting into the meat of the material, you get a homework. Next week after that, you return your homework, you get some more content, and the homework gets taken away by the TAs, right? The week after that, you start to get some feedback, right? A week after that, you probably get a test. This is way too slow. I mentioned Google can spot differences, within hours or within minutes. Why can't we do the same, right? And so there is an effort by many in academia to start to move to this direction, right? How do we start to create predictive models? And there are already experiments of this, but this is what we're moving to. These large platforms that have hundreds of thousands of users that give us really great data are what we're starting to leverage to try to start to answer these questions. And there is already literature. Opportunities are to predict performance, as I mentioned in the first day. This is an experiment that I ran in class. To help lower performance students, can we spot them quicker, right? If you're 3 weeks in, it's going to be next to impossible to be able to catch up, right? So how can we understand who we have? How can we challenge the high achievers? As we start to get more information into this platform, we can start to give broader recommendations. So if you took this course, that course, and this other one, we've seen a lot of people have success, right? Another thing that's happening as well is, and this is industry feedback from industry, is that the marketplace in university is not responding fast enough to what's happening in industry. And I mentioned what's happening in agriculture. I mentioned what's happening in other domains. For example, Monsanto wants people that have machine learning intelligence, that are good at hardware and that are good at 2 other fields. Nobody is training those type of students. So how do you find them? How do you distinguish them from all this data are big questions that are being asked, all the way to student wellness. We're already starting to get some insights into data. This should be interesting since I'm speaking here. Any guesses as to what rate you should speak at to be able to capture the attention? Do you think, a simpler one, do you think slower is better? Or do you think very fast is better? Slower is better? So I get divided opinions. Raise your hands if you think it's fast. Raise your hands if you think it's slow. Interesting. This is fascinating. Faster captures the attention better. So 150 is about standard speaking speed. 120 would be slow. 180 is faster. And what we find students doing is that people who speak at 120, what do you think they do? I mean, what?
Look down their phones.
Huh? Well, no, they speed it up. They speed it up. There are certain professors that are routinely listened to at double the speed because they're very slow, right? So here's another one, especially in this format. How long should, some of you here. How long is the ideal block of content? 15 minutes. It's actually 7 minutes. So 7 minutes. Have any of you ever timed a new Google product, how long the video tends to be? Yeah, it's about 2.5 to 3 minutes, right? I have students that tell me, I will never watch anything that's longer than 5 minutes, right? And so 15 minutes, I think, is the upper bound. And it doesn't mean you can't do, 6 hours of material. It just means you have to chunk it. And you have to, have assessment, and you have to have other things in between because nobody can hold their attention that long. Students preferred hand-drawn diagrams to PowerPoint. And again, I'm showing PowerPoint, right? Why? Why?
It's authenticity.
Authenticity. So I think parts of the response are all in what you mentioned. The biggest feedback was that it's slower. If I show you a full diagram and it's pretty and it has colors and it has labels and it has a lot of stuff going on, it's impressive to look at. But I have no idea what your thought process was in coming up with that. If you build it up from scratch, you get to accompany the content creator in that journey, and you get to connect with these ideas, and it is slower too. And yeah, well, yeah, but that's expensive, right? So anyway, and there is something about the pencil and the paper, and it just feels good, So my classroom, and I'll mention here some of the experiments that I'm doing. Before students show up for class, And this is in a reaction to what I saw in active learning. I mentioned that the first step that many of us took was to flip the classroom. That is, we asked students to watch the video and then come to the classroom and work on a project or work on applying the content that they had watched. The problem, and I did this for a year or two, the problem that I ran into is that I did not see the students having accountability for the work that they were doing. I saw a lot of the students would, start working on email or would wait till the solution was given and then would do the work. And there wasn't this hands-on, let's get this working and let's try to prove that I understand what I'm talking about mentality. And so the very first thing that I did is I asked them to watch the video and take a quiz before they came to class. When they showed up in class, I knew at what level they were coming in, and I could address things that I had noticed that they were missing. Now, in class, I changed to an accountability system. I wanted everybody to walk out of that class per session with a number attached to their performance. I wanted them to know where they were by the end of the session. The classroom changed dramatically overnight because everybody knew they were going to be evaluated what they did, and they knew they needed to submit this before the end of the class, right? And so what I did is I did 3 cycles of mini lectures. I would do 5 to 10 minutes, then 20 minutes of exercise, and I would repeat this 3 times. Each of them had a deliverable, and we in the class could also see the performance of the students as they were taking on this, these challenges. Now, I've been working, one of the things that wasn't mentioned or maybe towards the end, I've been working with corporate education for the last 10 years of my career. I've worked with the big consultancies that are global. I've worked with software manufacturers in the US. And the state of corporate education, especially in the enterprise, it's terrible. It's terrible. If any of you have ever done the death by PowerPoint, let me show you 5 slides and then answer a quiz, you know where this is, right? There is no thinking involved, in our understanding of the potential and knowledge of our workforce is very poor, right? So this is, the reason I mention is because there's tremendous amount of interest in this work in trying to quantify what my knowledge wants. There's even interest from companies that have products that the customer, say, is complaining because their engineers are not delivering on the use of the product, and they're interested in these assessment platforms to be able to gauge the knowledge of the engineers of using that product, right? And so the other thing I did as well is it wasn't just exercises in class. I moved to doing exams the same way. If any of you ever took a computer science class in college, and many still are the same way today, you take them on a piece of paper. There's a bit of code, and then they ask you to answer some in pencil and paper. What sense does that make? You do all the work on the computer, and then you come in and we give you a piece of paper, right? And we tell you, prove that you can do this, right? So I moved everything to be done online. There's really quite interesting war stories that we could get into about, can students cheat and all of that, but we'll skip those. So I was getting data from them before they came to class. I was getting data from them while in class. I was getting data from them on exams. I was getting data from them in forums. And all of this data together led us to develop predictive models and to understand what students were doing and their level of understanding. One of the things that I came away with is that I now clearly see that there's a market simply for building questions, because the level of granularity and the art of asking questions is a problem unto itself. And I'm not the only one. Many other people are working on this problem as well. The landscape is changing quickly. The amount of content and video being produced across the world is overwhelming. I clearly believe that content will go to zero. And I think our job as faculties or as leaders of a field will be one of curator. If you are an expert, you can clearly identify who is best. And we need to move away from this crazy practice that we have of across 3,000 universities in the US, everybody teaches and repeats the same class material over and over. There are clearly leaders, there are clearly stars, there are clearly models and exercises that work better. How do we start to understand that? Is part of the work that myself and many others are doing. How do you create this platform of learning that is scalable and low cost? That's the other point. Many of the experiments that I suggested to these companies that I was working with that I mentioned they come back and said, yeah, this is wonderful, but we have no ability to implement this, right? So a lot of the effort is going toward fundamental building blocks that are freely available to everyone, that can be used to lower that cost, so that it's really no different than what you're doing today. However, the experience and the amount of understanding that you have of your workforce is huge, and it's vastly improved. And there's a huge avalanche. This is simply to say here that there's a lot of people coming into the space. For people like us, this is the big challenge. How do you go against all of this innovation, and how do you change to accommodate this, right? Big names like Google, Amazon, Microsoft, all of them are introducing platforms. The investment is there as well. You can see there that it's steadily been going up. That one ended in 2015. It's about 3 times bigger now, roughly at about $1 billion in the US, VC investment in ed tech. There's already companies, the one I mentioned, Udacity, that's valued at over $1 billion. Google, these are some recent news. Last week, announced a $1 billion investment on ed tech. And this is one of the big ones, right? Have any of you seen this number before? 20% of today's workforce have the skills they'll need for 60% of the jobs that will exist in the next 5 to 10 years, right? So how do we educate our workforce? And how do we gauge their understanding? It's a huge question, because this is our main competitive advantage. And especially as you start to talk with companies that are not born in 2005 forward, there's a tremendous challenge that they need to address, right? And so this last part that I'll mention is about how do we bring it all back together, right? So here's another quote for you. Most programmers write in single player mode. One of the challenges, and this has to do with the challenge of discovery. I have no idea what the person in the office next to me is doing, down the hall, or in my department. How do we start to understand what we know? It's a huge problem. And how do we start to leverage this information to be able to create new products, be it in the educational space or in industry, for customers, right? Reproducibility, which maps back precisely to this question of being able to recreate somebody else's work, is at a huge problem point in history. So much so, in computer science, it's even worse, meaning that from a published bit of work, nobody can even recreate the work that has been done. So much so that NIH has explicitly started to dictate certain requirements of anyone that is publishing to make sure that that work can be reproduced, right? And in general, especially within data science, projects simply take too long. And the reason for this is that we are not leveraging the work that came before us. Every single MIT student that's walking around with a laptop has some sort of valuable IP in their machine. The great majority of them graduate and no one ever sees that work again. And nobody, while they're here in the institution, can connect to that work. The reason is that work is in their own environment, it's not available to anyone else, it is their own playground. And so how do we change this question is one of the things that we're addressing. The big difference that I would argue, and in many ways, some of you might think about this is reuse, right? Code reuse has been something that many people have talked about back to the 80s, right? This was what object-oriented programming was about originally. We will be able to create these clear, boundaries, and we'll be able to pick up these other pieces of code, right? Did it ever happen? No. It never has. However, I would argue that today's industry, it's built on reuse. So if you think about Uber, right, a common example, did Uber write their mapping platform? They did not. Who did they use? Google's, right? Did they write their messaging platform? No. Who did they use? Twilio's. And you go down the line. So these new companies are built on coarser building blocks and can create products a lot quicker. They move at a speed that the traditional or the legacy enterprise simply has not seen. I've been speaking with a bank, and I won't name names, but they have 6,000 programmers, and they are writing everything in C For those of you who are technical will know that that's not a productivity or a high or a very friendly language. Everything internally they write in C, and they always have, from the ground up, right? And everything that they distribute is still native desktop clients. Their deployment cycles are about 3 months long. This is by the time they're done, right? So when it comes to hooking on to these coarser building blocks that are now available in industry, they have no opportunity to do so, right? And so you can start to see, and the reason we're speaking with them is because they're starting to move into this space and starting to consider the possibilities that the modern digitally born corporations were born and raised in, right? And so, as I mentioned here, my argument is that there's an entire industry now built with building blocks that can be leveraged to create new organizations that are very agile, that have an ability to deliver products at a much faster pace, that can test in a quicker way. None of this, none, is being used in education, right? And as I speak to corporations, many of them don't even know what I'm talking about many times, right? So we have the same challenge that many traditional enterprise has, right? We have to bring in this agility. We have to be able to connect our tremendous IP that we're generating internally. And we have to create these playgrounds. So one of the things that we're working on is precisely a platform. And this is simply an example of someone that has done it on the IoT side. There's a number of products here that you can connect without having to write a line of code. You can connect a device to a service that somebody provides online, and you can then say get a notification in the mail. Or the simple thing you can sort of see here, turn on lights when you arrive. And what this does is that it senses from your home router that your phone ID is close by. It then sends the message to your smart light bulb at home to turn on the lights because you're home, right? All of this was done without any need to write a program. And all of these services were written independently without the consideration or the vision of this specific type of functionality, right? So this is very much what we want to move to within university at a more technical level. We want to enable our students to be able to start to connect all of the work that they're doing. A very concise example. I've been leading a center for the last 7 years, and we've developed approximately 30 models. Some of them for weather simulation, some of them for population growth, some of them for electricity distribution throughout a city, some of them for transportation, and so on and so on and so on. None of them are connected as of yet, right? All of them are still on that person's machine, right? And so what we want to do is when the new generation that comes in, and they come in every year, instead of them starting again from scratch and trying to figure out what they want to do and start to build, they already have a platform of services that they can start to use and integrate to build on top of that to be able to create new models at a quicker pace. Not only that, we can start to address questions that haven't been considered, because many of the models get written independently with a certain vision in mind. Once you can start to use them as modules, you can start to compose this fabric of this model feeds into the next, which feeds into the next, which feeds into the next. None of that is available at the moment, and this is something that we're doing. And so the very first time we put a model up, all of a sudden, 100, 200, 300 people started to use it that we didn't even know, right? And so you can imagine that this sort of pairing goes really well with the cloud services and where you have tied for execution. A very simple example is a sentiment analysis. You can do it in everything from your restaurant to if you're trying to buy a stock and you want to crawl the entire network or the entire internet. By the way, how long do you think it takes you to scan the entire Eyepieces of the world? And I mention this because oftentimes it's good to be able to challenge old assumptions. So there's trillions of IPs, right? There's everything you want to imagine tied to them. Everything from a PLC in an oil field to the machines that are attached right now to create this PowerPoint presentation. There's trillions of them. If you were to, Google does this periodically, right? They crawl the web, and there's about 1 trillion documents that they index and that we use to search on, right? How long do you think it takes you to scan the entire world of all the IPs? Days, months, years? seconds. Wow. That's impressive. So to cut the suspense short, it takes 6 minutes. But that is a fundamental premise change. And this, by the way, is off the chart. Should be really daunting that you can actually do this. There are new security companies that are going out in the market based on this premise, right? Because if you can scan the entire internet, you can start to get intelligence, you can start to try different ports, you can start to do many other things, right? But again, just like many things used to be hard and are now simple, this is one more, right? Long story short, we created a platform, and this platform has started to be used, and it started to be leveraged. After all, what we're looking for is analytics, right? We want to understand what's being used because we want to make this a college-wide platform. We want to understand what type of usage is being made off of these modules. We're tying them to a pricing model that is no different than anything else that exists on the cloud. So we would address abuse from that standpoint, meaning if somebody wants to, I mentioned sentiment analysis, if somebody wants to upload, say, a gigabyte of text, that's fine. They would pay for it on their own. And we can start to create this set of resources that start to provide a level of functionality for research teams around the world in a way that has never existed before. Not only that, you can start to do the exact same thing for industry, right? We have many collaborations with industry. Why couldn't they start to connect in the same way, right? So in general, this has been a bear, right, to be able to realize, because it has to do with a culture change. If I go back to this slide, this is not a stack of technology that is being used in university, right? It is still the model of the lone researcher that works in his office, disconnected from the world, building some model that only he cares about for the time being and eventually will be used by others. But he does not create something with this vision of being part of something bigger, right? Or of being able to allow others to use it. And so part of our design process has been in how do we permit that independence of thought while at the same time allowing them to plug in and many others to share in the content that was created or the intellectual property that was created, and at the same time provide feedback. And not only that, within these communities, they can even contribute to what this is, right? Because oftentimes this is a common practice within academia and a common practice within software communities of saying, you're dropping the ball over here, or you need this extra functionality, let me provide to you that piece for free. And this is a continuous practice, and this is how software platforms of the open source are built all the time, right? So we're very bullish on this approach. We've had really great adoption, and we're moving forward. And I would say that in general, this is the challenge that as we speak with corporations, we see as well. How do you create products faster? How do you integrate your information? How do you start to get buy-in in these platforms? So with that, I'll go ahead and stop, and thank you for your attention. Yeah.
So oftentimes, when kids go to college, including myself, you don't really know what you're going to do, what you want to do. So with all of this, it's just obviously very, very good, but how do you not remove the human element of a great professor, a great educator, and having that interaction that can drive motivation? I mean, I know we're moving to, it looks like, where they have to prove what they can do. How do you not remove that human element out of education?
So the question is, if you didn't all hear it, is there's a star professor, and having access to him is tremendously valuable, right? The challenge is the amount of people that can access that star professor is quite small, right? If you think about the amount of people in the graph that I was showing about MIT that can come to MIT, is about 8%, right? What about the rest? And although we will never be able to be as good as we are in person, right? Having that professor communicate through a platform that makes it accessible and free to the world is a huge resource, right? Now, in the residential institution, right, we're talking about all of these tools to improve the quality of the experience in the classroom, right? Not to replace it, right? So we're still there. And as I mentioned, for example, how many people say are teaching calculus in the first semester of college throughout the country, right? There's thousands of them, right? There's some that are stars. Could we start to think about the content of the class, not the mentorship, not the guidance, not the feedback on the work that you're doing, but just the content, say the voice that's speaking and that's transmitting that message as we did the textbook, right? So it was rare, the class that you took, that the professor had actually written the book, right? In many places around the world, there was a certain book that was a standard, right? So in this case, can we start to do the same thing with the professor that is the star, that is making a difference, that is really connecting with people? As I mentioned before, we have no idea right now who that is, right? We have no ability to understand that, right? But if we can, then we can start to provide that content while keeping, I don't believe that until, very long time from now, when robots are running the world, we will do without the professor. Because I've seen many efforts to try to run purely online. When you have a person in the classroom, when you have a person that's leading, that's providing feedback, that's inspiring, that is coordinating the effort that is being done, that is adjusting when there's problems and so on, all of this is complementary, right? And so that's the perspective I would take. Yeah.
Cool. Okay, right. So I have two questions.
Yeah.
How long do you think it will take for education to be free to all that want it? That's my first question. I'll give you my second question because it might go along with that. How does this now change the credential model that we have? So, you have to have credentials before you can practice. How do you see that changing?
So terrific questions, especially the second one. The first one is, how long will it be till education is free? It's free now, right? To all. Well, to all meaning those that have connectivity, right? I know that there's a digital divide, and I know that there's parts of the world, for example, rural India and rural many places, right, that simply do not have access. Given the advances that are taking place, I think that will be alleviated. If nothing else, the platforms, the dumb cell phone that, it's under $100. And I know $100 is a lot of money in many places, but it's an investment that, say a village could make, right? Can already go to the city and sync up and load up on some of this, right? So that's the I think the question of cost, right? The credentialing piece is fascinating because, and this is the conversation I'm having with my wife. I say to my wife, don't get excited. Just listen to me for a second. What if he doesn't go to college? Right? And after, she climbs off the roof, right? I say, look at this. If you take a look at a person right now, going straight from high school to the computer science industry, right? And you project their earning potential and the place they will be at 22 versus the fresh graduate coming out, they're actually doing better, right? The high school student. Now, I know this is computer science and they are unique in many ways, right? However, there's starting to be mechanisms that are not the universities. So for example, GitHub is a popular repository through which the entire software industry posts their code to. So you can think of it as a Facebook, but for code, right? Maybe that's a bad analogy, but roughly speaking, right? There are stars born in this environment. The code bases, for example, that run many of the world's systems have their place in GitHub. The Microsoft team, when they launched their newest editor, which is one of the fastest growing and fastest adoption, they launched on GitHub. And within GitHub, they continue to distribute the code. The reason I mention this is that if you develop a piece of code that gets adopted, the world will beat your door down without you having to look for anybody. And there's many companies already that are starting to address precisely the question that you brought. They're scanning GitHub, they're scanning the projects, and they're looking for the patterns that identify those people that are valuable, that don't have the credentials that will get them in the door for an interview. There is a tremendous amount of bias still in our interviewing process. Many people will say, so I have an MIT resume and I have a resume for a no-name school. They sort of look the same. I'll go with the MIT one, right? And this is, MIT students would say, this is what you pay for, right? However, you don't know which one is better if they look the same, right? This effort that I mentioned to start to scan and look at code and mechanisms that are similar to it are starting to quantify and move again away from intuition and versus more objective measures, right? So there's starting to be some of those. In this industry that I'm part of, the computer science industry, it's doing really well. And it has some great products out there that are looking into some of these questions. In general, the threat to us now will be, is there going to be similar communities that their blessing on you will give you the equal value? For example, you're a star on GitHub, it bypasses any MIT curriculum coming out, right? Because you're proven on the market and people know you and the community recognizes you as a leader and a star, right? That's money, right? If you are a graduate, again, you're a question mark, right? And so will the world start to create these communities that their stamp of approval on you creates that market value is the question. Within the star computer science community, there's no question that they already exist. Within the data science community, there's no question they're already there, right? However, can this go, to the economists, to the lawyers, to the accountants, et cetera? A lot of the platforms that I didn't talk much about blockchain, but blockchain, for example, has a mechanism through which, you could start as a professor to be independent and license content, and you could have a license for those that are nonprofit for free, and you could have a license for those that are in corporation that establishes, and it could be automated, and they needn't be any meetings, and there needn't be any other things. This can be a platform for many other professions as well. I visited the law school at Harvard a few months back, and I was surprised. I felt like I was speaking to computer scientists. And the reason is that they feel that a lot of the law will move to these platforms. And there's the question of smart contracts, that if we have agreement and we can execute, then we don't need lawyers. Then we don't need to send the invoice. We don't need to get involved in any legal resolutions, right? If contracts are not enforceable, we have to go to the courts. This is a system that will automate that transaction and that enforcement, right? Without any humans involved, and the efficiencies, as long as you say no lawyers and you say no government, you already have, huge efficiencies, right? But this will go a far way towards supporting communities that start to emerge that are independent. Some of them, talk about the gig economy, and this might be the formalization of some of this to where, people truly can work independently and develop that brand, right? Because if you are engaging with, industry or with others, and they are assessing your value, you will start to have a reputation, right? And there are, for example, I have colleagues that are working precisely on this, on these networks, and there's money that gets exchanged for reputation. So, for example, if I truly believe in you, say I'll put $5 on you, and then somebody else puts $5 on you, and the community rewards, and the community also detracts. And so you have these ecosystems where you can start to have some of this. Now, this is, sort of next generation type thinking, but there is the effort to try to start to create these infrastructural pieces that will start to recognize that expertise. And that is a great place to be in because, again, from an objective skill viewpoint, you can start to assess in a very different way, right? And so, again, the challenge to us is if the piece of paper no longer has the same value, what value do we have? And hence the startup, right, with Harvard and many other experiments that we're doing, right?